Yeah, you must be here with the ladies, huh?
I do all right, you know. It's about 5 or so.
Yeah, I know what you're talking about. I got 5 too, you know what I'm saying? Shoot.
Don't look like 5 to me.
Hey, hold up. All right, whip it out on 3.
Yeah, all right.
All right, 1, 2, 3.
See? That ain't 5.
Oh, hold up. I forgot to tell you. I'm a grower, not a shower. You know what I'm saying? Boom! Hold it up. Yeah. Ladies and gentlemen of YouTube, welcome back to the Folding Drone Community Series. And I apologize for a very long delay since our last update. But it doesn't mean that we weren't busy working hard at something, because we have been. In fact, we are pretty much at our final stage, and it all actually fits into here. Now, to get into all of this, I don't want to talk about it because we've been at it like since day one. However, I am going to invite Ryan, our star designer, on this project, who's going to basically tell you from day one to how we got here, because you can't see it yet, but there's a lot of stuff over here to discuss. So, sit back, get your popcorn out, maybe get a beer. This is going to be one for all the people who really like to get into the technical details about how design works in our particular process. And if you're not into this kind of thing, go get a beer and listen to it anyways, because we need the analytics. So, without a doubt, Ryan, get over here.
All right, y'all. Let's get into the nitty and the gritty, all right? So this has been a long journey, and we'll show some B-roll. We started out with just a rudimentary little, thing with no motors, no arms, no nothing.
Yeah. That's what you all voted on, and that was like the original idea. But we said, well, we can do better. We can do better. So this is, you wanted something folding. You wanted something that can crash, that can get beat up, and all that stuff. And we tested it out. And y'all wanted it to be cute. Y'all wanted to be able to fold it up, put it in your tiny little fanny pack, and then go out and fly in like 2.3 seconds and gets going. You know what I'm saying? But I'm done. Ryan, keep going.
Yeah. So yeah, you wanted something small and cute and compact, and we did that. We made it small, cute, and compact. Obviously, it fits in this nice little case right here. But it was a long journey to get here. We had to do...
Yo, can you get it? Just show them the stuff. Like, what did you start doing? Like, you, man, just talking, you know what I'm saying? Just keep going.
Well, let me start with the basics. We know that we started right here. You guys have seen this. You guys saw this. It started with a push button.
B1!
Button. We started with a B1. It was just a push button. We push this button, the arms fold. That was just to much work, so you have to hold it down.
No, hey, screw that, man. That's just too much work. You gotta push a button. Hey,
we don't need that. All right.
Back to the drawing board. That's what I tell him.
Back to the drawing board. And then I did this. This will fall apart. We're not dealing with this anymore either. This is terrible. That was how we started. That was when we took this little block right here, and then we changed it into something that looks like this block right here. Little 2-step, little action right there. Those had vertical sides. The sides were flat, and therefore that made it so the tolerances had to be spot on. It had to be perfect little tolerances. If you crash and then you put a dent in that block, that means that you might get a little wiggle. We don't want wiggle.
And then I said, no, none of that. It's got to be robust. It's got to be durable. You know what I'm saying?
My hype man right here.
Keep going.
Yeah, I mean, because my money don't wiggle, right? So we had to change to an angled block, which you might remember from a previous episode. If you don't, we angled the sides so that as the more it gets pushed down, the harder it pushes against the arms, which makes them more stiff and robust. That's what this guy had.
Because y'all said durable. We needed durable. So look. Can we see that? No, we can't see all that.
Can't see all that.
Can you show them like how many? Like, oh.
Here.
No, I got it. Right here. I got you. I got you. You keep going. I'm messing you up.
And so this center block was a huge thing. We had so many iterations. This isn't even all of them. This is just the ones I could find left over. We had to keep printing things and printing things and printing things.
Oh, hold up. Speaking of 3D printing, shout out to Soval. They was actually paying attention to this series earlier on and said, hey, would you guys like to see a 3D printer? It might help you with your R&D process. And I said, yeah, I think so. Ryan, what do you think?
Yeah, 3D printing was crucial. Obviously, everything, including our final design that we have right now, is 3D printed. So we're printing every single day as I'm designing this.
All right, hit them with something that you like about this printer.
Well, for one thing, it's got a bigger build volume than an Ender 3 or even our Prusa over there. And it's direct drive, which I love. I only will print with direct drive machines. It's also got a filament runout sensor, which saved our butts on 2 occasions where we ran out of filament overnight, and then we were able to resume the print right afterwards.
Oh yeah? And how does this help your process?
Well, it means that I didn't have to stop. I just kept on going. I didn't have to do any setup because it's a Soval SVO1 Pro, which in Cura is already built in. You just add a profile, add a Soval SVO1, and you're done.
Shout to Soval. Y'all should check it out. All right, let's get back to this.
All right. So that center block was a huge thing to figure out. We had to get the angles right. I started out with 5 degrees. That wasn't quite enough. It was too easy for those little 5-degree angles to get bent in. So I increased it to 10 degrees. And then something else that changed was the thumb screw itself. So we started out something small, 4mm screw to try to like an M4 screw to try to move this block. You can see down the center, there's a hole right there. We started out with M4. That worked all right. That moved the block up and down. And then ultimately I thought that was too small, so I upped it to an M5.
Was that this right here?
Yeah.
Yeah. So he's all like, hey, I saw this. You just gotta spin this. And
I was proud. I was proud of it.
And then I sat here and I was all like, okay, cool, so let me try it.
He was like,
and then I started doing this. And I was like, holy shit. Oh man, I feel like my facial hair is starting to grow. I said, no, back to the drawing board. That take too long.
Took way too long.
I want it to be easy for you.
Yeah, it was too many turns. So then I tried to go. I was like full lock the other direction. So then I went to an Acme screw, which is like super coarse threads. It's basically what you might find on right there on the Z-axis of that. It's like something that moves machinery up and down. That was just too much because then I'd have to custom make something special, like this special custom part, and have that made.
And then I said, no custom parts.
We ain't got it like that.
This needs to be cheap.
Too much money.
It needs to be cheap. You guys need to be able to afford it. Keep going.
Yeah. So that was 1/4 inch, but it was I think it was 12 teeth per thread. So then I had to like figure out what's more common than that. 1/4 20. Camera tripod screw, right?
And then I was all like, oh, yeah.
We got these.
1/4 I know all about 1/4 We know what 1/4 Okay, keep going. Keep going.
And then also I had to figure out how do you keep it retained. And originally I had a little C-clip notch in there to try to make it so it holds it from the top and the bottom to make sure that doesn't wobble. But then I was like, man, that's custom stuff. And I found this right here. This is a shaft collar, has a little set screw, and then that will go on the 1/4 and keep it retained. Keep it in there, keep it good. And then that solved that part. But then that didn't change from
and then
trying out.
And then what happened, Ryan? And then what happened?
All these different blocks to get the depth right, because we want it to, when you thread it up, when it goes up, you want it to stop. When it goes down, you want it to tighten. So I tried iteration after iteration, probably 15 to 20 of them.
And I came in here and I was like, Ryan,
different top plates.
What is all this? You're just spending so much.
Yeah.
You spent like 2 weeks on just these.
I wish it was only 2 weeks. It was a lot. I spent a lot on printing a bunch of different versions of these, different threads, different types of stuff. And finally, we got that nailed down. The mechanism worked. It took like 5 turns to get it from full bottomed out, full top. Everything was great. It was
and I was all like, that's it? And now we can do it?
That's all you need, bro.
Boom! Move forward. Next thing.
Boom. Next thing. Now we had to talk about how the arms fold. In the comments section, we noticed you guys said you wanted the arms you want to be able to keep the motors on the top, you want to be able to fold past each other, and you wanted a little bit of motor arm protection.
And you know what? For the record, I agree with y'all. No top and bottom. It should just be all on top, man.
Hey, I get it. I just wanted to go crazy at first. I thought, let's do something crazy and wild. But you know what? So we started out, no arm ends. We started out with nothing, because all we cared about was the way it folds. Then we moved on to something like this. This just holds the motor. That's all I cared about. Then we said, okay, well, this is the diameter of the motor. I'm going to try that out. Then you guys said, no, we want motor protection. So then I did motor protection, but I had to angle the motors to try to make the wires flow the right way. That all got sorted out, and now we are where we are. Let me show you what's in the box.
Ooh, you show them.
You want to see what's in the box? Let me show you what's in the box.
Show them.
Bam, this fits right inside here. Maybe we'll do a giveaway with this box. Maybe we can do something, I don't know. We'll figure that out. But this thing is nice and compact. Here's the quick overview of it, all assembled and all folded. Right now, the electronics that I have in here is I have a SpeedEB AIO all in one because that's what we like to use. We like to use AIOs. It keeps electronics simple. We have.
Hey, but can it fit a double stack?
It can fit a full size stack.
Double stack.
20 by 20. I didn't want to do 30 by 30. There's just way too many holes in there. Too much hardware to worry about. It'll do a 25.5 by 25.5 whoop style AIO board in there. Same with that's why we also have the walk snail in here.
And it'll do 20 by 20.
And 20 by 20. And we've got a neat little system in there that we'll show you later how that all goes in. And we have the walk snail avatar system in there right now, just because I wanted to show that it fits that. Obviously, it'll fit
air unit,
an
DJI,
air unit.
Boom.
That's the easy thing. That's easy. It's 20 by 20. If it fits a stack, it fits the Vista. So let's show you how it works. Obviously, we have that little thumb screw right here, a little D-ring. You just unscrew it. Oh, it's already unscrewed on this one. You just unscrew it all the way, and then flip the back legs out first, front legs around. Now you have it fully deployed, and then you tighten. I don't know if we can see. This guy's excited. So now, when you're turning this, you probably can't see on camera, but in the center there, the block is moving down between the arms. But once it's locked and you feel it tighten, then you just, it's in there. It's in there. It's robust. It's strong. This is just a 3D printed mock-up, but it's the final design. Everything is done as far as the way it's going to look, and that's it. Now it's locked. If you want to go the other direction, you want to close it up. We go backwards. We go counterclockwise until it gets tight, till it completely stops turning.
Yeah, there's no guessing. It just stops.
There's no guess. You go all the way till it's tight in one direction, all the way till it's tight in the other direction, and then that changes whether or not you can fold it or not.
Boom.
Always do the back arms first, and then close it up. And then let me point out something that this damn near broke me. I swear, I almost threw in the towel. I almost said, Tommy, we can't do this. This is not going to work.
And then I told him, you suck. You can't figure this out.
The wiring was a nightmare. Every time I moved this arm right here, it would get pinched or caught or bent and sticking out. There's wires hanging everywhere. I had to figure out something. So I started modeling things in CAD because that's how I think. That's the running joke around here, is that I can't think of anything for real unless it's in CAD first. So I did it. I made this little model in CAD.
If you ask this guy to make you some espresso, he'll tell you, I'll model that in CAD and build you a jig.
That's a great idea. I'm going to do that. Anyways, yeah, so you can see the wiring has this little hinge point. You notice that it's stiff right here because of the heat shrink here and the heat shrink here, and then there's no heat shrink right there, which means it's always going to pivot right there, and that's the same situation for here. And then those tuck nicely into a little cubby hole that I created, even on the back. Let me show you the back. They tuck away inside the little cubby hole underneath there. Same thing. That tucks away because it's set to bend in a certain way. So now there's no extra wires hanging out. Look, there's no wires hanging out anywhere. This thing's ready to go. And then obviously to lock it down, you just crank the thumb screw. Bam. Bob's your uncle, and he is a hell of a pilot. There it is.
So basically what you're telling me is that with the exception of this piece,
Yes.
this is the one custom piece, and we're going to make this out of aluminum because there's constant friction. Things are up and up against it. We don't want to make that out of carbon because we know better. But this is the only piece that's going to be custom. Everything else is off the shelf, which we tried really hard to make sure that as much of this is off the shelf because we heard you. Y'all don't want to pay an arm, a leg, and the left testicle. So that's what we were trying to do.
Maybe they're right. Right's expendable.
Maybe they're right. Maybe they're right. But that's it, folks. Is it what else?
That's it. Yeah. I mean, like I said, It took me forever to figure out that whole mechanism of how the thing folds. It took me even longer to figure out how to make the wires fold without crashing into each other. But I think that what we have right now, if this were carbon, which it will be very soon, I think we're in production right now to make the carbon version of the prototype. But there's no more design changes. As far as I'm concerned, this is production ready. And then we're ready to actually make a folding drone that will fly great.
All right, get out. Time for the outro. All right, y'all. So it's been a long time coming, but we are here. This is pretty much the final design. If you are just catching up with us now, we've had several videos from the inception to the voting of this thing. We've flight tested, just to make sure that the frame resonance wasn't going to be a problem. The thing after that to solve was I said, hey, Ryan, I really want to make, this is locked right now, but I want to make sure that it feels good, because after all, our inspiration was how knives fold. And so we wanted to borrow, whatever design ideas and creativity and transfer it into here, because at the end of the day, this is going to be heavier than your typical quad, but it folds. And if it's going to do all that, then it might as well feel really solid about it. And that's probably my most excited thing about this, isn't the fact that it folds itself, but just how we solve the folding mechanism so that it still maintains its durability even after a crash, which I don't know if that point really got across, but that's why he went through like 50 million revisions of this, because this centerpiece is really the key thing that's holding everything together. And after a crash, things start to get a little loose, the tolerance starts to loosen up a little bit, and we wanted to be able to keep this in a, design this in a manner where you can keep cranking it down and it makes it tight again, because that's typically what happens. You crash, things get loose, you should be able to just tighten it back up so long as nothing broke and everything is good, and that is exactly what we have solved here. But that brings us basically to the end. So where do we go from here? Well, we need to cut out a prototype directly from our manufacturer just to make sure that this actually looks and performs and goes together like we expected in its carbon form. And then after that, we'll be testing out the different motors that we have picked out. And then we just got to come up with a name, because then we're going to put it into production, and then you guys can go ahead and put your pre-order in, and we'll make sure that everybody that gets in on the pre-order actually gets one of these. So that's going to do it for this video, folks. My name's Tommy. That guy was Ryan. We'll see you guys on the next one. Peace out.
Working with like about 5 inches. Wait, what? I'm working with 5 over here too.
Yeah. Stop.
You all right? Yeah. How's What was it again?
1, 2, 3.
Yeah, that's what I thought.
Faster.